Let's look at the basic symbols of Bpmn 2.0. The basic symbols of Bpmn are a start event, represented as a circle with a single thin line, an end event represented as a circle with a single thick line, an activity, which is represented as a box with rounded corners, and a sequence, which is represented as a full arrow. As you can see in the diagram at the bottom of this slide, I draw my Bpmn process models with a tool called Visagi Modeler. Visagi makes use of colors. Colors are optional in Bpmn, so the standard notation is actually a black and white notation, but the use of colors can make a process more understandable. And so Visagi uses green for start events, red for end events, and blue for activities. But the use of colors is not mandatory, it's optional. In order to understand Bpmn semantics, it's important to know that Bpmn comes with token semantics. Token semantics is something that comes from Bpmn models and that is also used in Bpmn. A process model, so a diagram of a process, represents a set of processes, and all these processes will be executed according to the model. A process instance represents a single occurrence of a process. So for example, suppose that you describe the procedure to apply for a master program at a university. This procedure can be documented as a process model, so you can document it as a Bpmn diagram. Every individual application that occurs then is a process instance and is in fact a single occurrence of the application process. Now we can represent a process instance by means of a token, and in order to distinguish the different instances from each other, we can make use of color tokens. So every token receives a color, and in this way you can follow the process instances as they go through the process. And the idea is that a start event spawns the tokens. So let's look at this very simple model at the bottom of this slide. So you have process number 1. It consists of two tasks, task 1 and task 2, that have to be performed in sequence. This is your process model. When a process instance is created, the start event will spawn a token. So here we see that the start event spawns a red token. So we have one process instance, the red process instance. This process instance is in the state where it awaits the performance of task 1. So task 1 is started but not yet finished. Then a second process instance is started, represented by the green token. Also, this process instance is in the state awaiting the performance of task 1. When task 1 is finished for the red process instance, the process instance moves to the state where it is awaiting the execution of task 2. A third process instance is created, and so the blue process is in the state awaiting the execution of task 1. If task 1 is executed for the blue process, then the blue process moves to the state where it awaits the execution of task 2. And so on. So now we see task 2 being executed for process 2. So it means the blue process, so it means that now the blue process is finished and the blue token will disappear. So in this way you can see that how the tokens allow you to identify the process instances and also to see where these process instances are at which task, and so it gives you a view of where the work is and how the work is performed. You can follow tokens, see how fast they go from start to end. You can see tasks where tokens are accumulated, and so on and so on. So these token semantics allow you to have a good perspective on how the work is going on for a particular process model. So these were the basic symbols. There are a few other symbols explained in separate presentations. We have one presentation that explains the gateways, represented as diamonds, and you have split and merge gateways that allow you to merge parts or split paths in your process model. And then we have a second presentation that explains pools and lanes, and in the context of that presentation we will also explain what messages are, which are represented by means of dashed arrows.